What if I told you that right beneath your feet, yes, right now, isn't just solid rock and molten metal, but vast open spaces, maybe even lost civilizations or an internal sun? Crazy, right? Well, for centuries, this wasn't just a wild fantasy, it was a serious idea, grabbing the attention of everyone from famous scientists to eager explorers. The whole Hollow Earth idea has bounced around in myths and even sparked real-life expeditions. But what happens when these old tales crash head-on with modern science? The idea that our Earth is hollow is one of those super persistent and imaginative concepts that humans have come up with. It's this theory that our planet isn't a solid ball but more like a shell, maybe even with whole other worlds tucked away inside. So today we're going on a bit of an adventure. First, we'll dig into the fascinating history of these Hollow Earth theories. We'll look at where they came from ancient myths all the way to surprisingly scientific-sounding proposals from respected thinkers. We'll see how this idea really got people's imaginations firing and even pushed some folks to go exploring. Then we're going to switch gears and see how these captivating stories stack up against the hard evidence from geology and physics that pretty much tells us this amazing, long-lasting myth is, well, a myth. So what's really under our feet? Let's find out. The idea of a world under our own is practically as old as storytelling itself. So many ancient cultures believed in underground realms. These were often places like afterlives, homes for gods, or even where humanity first came from. Think about Greek and Roman myths. They talked all about underworlds like Hades, and some Native American tribes like the Hopi and Navajo have creation stories about people coming up from inside the earth. Now, these weren't scientific theories, obviously, but they definitely planted the seed that there's more under the surface than we might think. It took a while for these myths to turn into something more like a structured, though still pretty out there, proposal. Fast forward to the late 17th century and you've got a big name in science, Edmund Halley, the comet guy. Halley was scratching his head over weird changes in the Earth's magnetic field. So, in 1692, he threw out this idea: what if the Earth is a hollow shell, about 800 kilometers thick with two more shells inside it, and a core at the very center? He thought each of these shells had its own magnetic poles and spun at different speeds. He even imagined that the spaces between these shells could be filled with glowing air and might even have life. Halley thought that gas escaping from this inner atmosphere could be what causes the aurora borealis, the northern lights. Now, Halley was trying to solve a real scientific puzzle with what he knew back then, but he accidentally gave a huge boost to the whole Hollow Earth idea. His theories, as wild as they sound to us now, actually had a tiny bit in common with our modern understanding of a layered Earth. Except his layers were empty. So, how they got the ball rolling, but the Hollow Earth theory really took off and became a public sensation in the 19th century. And a lot of that was thanks to an American guy named John Cleves Sims, Jr. Back in 1818, Sims, who used to be a US Army officer, announced to the world his big idea. The Earth is hollow, people can live inside it, and it has several concentric spheres, and here's the kicker: he claimed it was open at the poles with huge holes. People started calling them Sims holes that were basically doorways to the inside. Sims wasn't just thinking about this stuff, he was all in. He started a nationwide campaign sending letters to politicians and newspapers promising he'd dedicate his life to proving his theory. He even tried to recruit 100 brave men for an expedition to find these polar openings and explore the warm, fertile lands he was sure were down there. He pictured an inner world, maybe with its own unique plants, animals, and who knows, maybe even its own people. It's not totally clear why Sims believed all this so strongly, especially since it went against what science was saying even back then. But his ideas, even though a lot of scientists laughed at them, really caught the public's imagination. It tapped into that 19th century spirit of exploration and national pride. He actually got quite a following. One of his supporters, James McBride, even published a book in 1826 called Sims' Theory of Concentric Spheres, which laid out Sims's ideas more formally. Then there was Jeremiah N. Reynolds, a newspaper editor who first joined Sims on his lecture tours. Reynolds was a fantastic promoter. Even after he and Sims went their separate ways, he kept pushing for polar exploration. His constant efforts were a big reason why the government started seriously considering such trips. In fact, Reynolds's campaigning helped get the U.S. exploring expedition of 1838 to 1842 off the ground. While that expedition led by Charles Wilkes wasn't specifically looking for Sims's holes, the excitement stirred up by Hollow Earth fans definitely played a part in making it happen. Even President John Quincy Adams, who thought Sims's theory was a bit nutty, still considered Reynolds's later ideas for a trip to the Southern Ocean. That just shows you how far the idea had spread. Other thinkers jumped on the bandwagon too. Sir John Leslie, a Scottish physicist, suggested a hollow Earth in 1829. And William Fairfield Warren's 1885 book Paradise Found, which claimed humanity started in a sort of underground Arctic paradise, added more fuel to these imaginative fires. Poor Sims, though, despite all his efforts, ended up broke and died in 1829. But there's still a monument on his grave in Hamilton, Ohio, a nod to one of history's most dedicated believers in a hollow Earth. The idea of a secret world hidden right under our feet, well, that was just too good for storytellers to pass up. In the 19th and 20th centuries, the hollow Earth theory dug its way deep into books and pop culture, going from a quirky scientific idea to a go-to theme for adventure stories. An early one directly inspired by Sims was Adam Seaborn's Simsonia, A Voyage of Discovery, which came out in 1820. But when you think of literary journeys into the Earth, Jules Verne's 1864 classic, Journey to the Center of the Earth, is probably the first one that pops into your head, right? Verne's amazing descriptions of a huge underground world with prehistoric monsters and an ocean down there totally hooked readers and made the hollow Earth a kind of fantastical playground for the imagination. Later on, Vladimir Obruchev's Plutonia from 1924 imagined an inner sun lighting up a world of ancient creatures inside our planet. These stories, and a ton of others, took that basic idea of a livable interior and just had fun with it, creating super exciting tales of exploration. And the fascination didn't stop when movies and other media came along. The Hollow Earth has been a pretty regular theme in films for decades. Think of old ones like The Mole People from 1956, and even recent blockbusters like Godzilla vs. Kong from 2021 have a hollow earth, showing it as this ancient place where titans come from. It just shows how this idea still grabs us even in big modern movies. The concept is also a big part of video games like the Gears of War series with its underground hollow. TV has played with the idea too. Even Star Trek had an episode called "For the World is Hollow, and I Have Touched the Sky," about a society living underground. Outside of fiction, the Hollow Earth theory still hangs on in some conspiracy circles. These days, the beliefs sometimes get mixed up with claims of secret advanced civilizations, hidden Nazi bases in Antarctica, or connections to UFOs and legendary underground kingdoms like Agartha. Even though it's been totally disproven by science, the idea keeps popping up, often fed by personal stories or new takes on old myths. This just goes to show how much we humans are drawn to the unknown and the idea of big hidden mysteries, that feeling that there's an undiscovered world just out of sight, waiting to be found. That's a powerful pull. So we've peeked into ancient myths, followed the passionate efforts of 19th century believers, and seen how the Hollow Earth became this amazing landscape in our collective daydreams. It's a pretty cool story full of wonder and that what if excitement. But now it's time to flip the script. What happens when these awesome stories run into the cold, hard facts of modern science? Let's get into the evidence that tells us what's really down there. For ages, what lay deep inside the Earth was a giant question mark. Basically a blank canvas for people to paint their wildest guesses on. But over the last 100 years or so, science, especially seismology, that's the study of earthquakes, has given us tools to look deep inside our planet, not with fantastical submarines or anything, but with the clear, precise language of physics. And what these tools show us is a world totally different from those hollow caverns people imagined. The most powerful evidence we have against a hollow Earth comes from studying seismic waves. You know, the waves that earthquakes create. Even big man-made explosions can generate them. These waves travel all through the planet, and seismologists record them at thousands of listening posts all over the globe. How fast these waves travel and how they bend or bounce depends on what they're passing through, things like density, temperature, and whether it's solid, liquid, or gas. Now there are two main kinds of seismic waves. P waves, think primary, and S waves, think secondary. P waves can zip through solids, liquids, and gases, but S waves, they can only travel through solids, and this difference is super important. When a big earthquake happens, S waves are seen traveling through the Earth's mantle. That's the big layer under the crust, but then they just stop at a certain depth. This creates an S-wave shadow zone on the other side of the planet. What does that tell us? It tells us there's a liquid layer deep inside, and that's Earth's outer core. If the Earth were hollow or had huge empty spaces, S-waves wouldn't act like this at all. They wouldn't hit a massive liquid roadblock. Plus, by looking at the travel times and paths of zillions of P waves and S waves from earthquakes all around the world, scientists have built up a really detailed model of what Earth looks like on the inside. This model shows a layered setup, a pretty thin, solid crust on the outside, then a huge semi-fluid mantle. It's mostly solid but can flow like super thick honey over long periods. Then a liquid outer core made mostly of iron and nickel. And right at the center, a solid inner core, also mostly iron and nickel, squeezed under incredible pressure. There are no giant empty caves, no shells, with atmospheres between them. Instead, it's solid or liquid all the way down, just with different densities. The way these seismic waves reflect and bend when they hit the boundaries between these layers is like giving the planet an ultrasound. And it confirms this solid layered structure. Some really recent research even hints that the very surface of the inner core might be changing and deforming, showing just how dynamic and complex the Okay, so seismic waves pretty much blow the hollow Earth theory out of the water, but there's more. Other basic physical facts about our planet really slam the door shut on the idea. Let's talk about gravity. We feel Earth's gravity all day, every day. That pull comes directly from Earth's mass, how much stuff it's made of, and how that stuff is spread out. Scientists can figure out Earth's mass by looking at how strongly it pulls on things on its surface, and on other stuff in space like the moon and our satellites. Now, if the Earth were a hollow shell, or even if it had really big empty bits inside, its total mass would be way less than what we've measured. And if the mass was less, the gravity on the surface would be weaker. Think about it. If you had a giant chocolate Easter egg that was hollow, and a solid chocolate ball the same size, the solid one would weigh a lot more and have a stronger gravitational pull, right? Our planet's measured mass and density fit perfectly with a solid, layered body that's densest at its core. There's just too much material making up the Earth for it to be hollow. Then there's Earth's magnetic field, the very thing that got Edmund Halley thinking about his multi-layered hollow Earth in the first place. We now know that Earth's magnetic field isn't made by a bunch of nested magnetized shells. Nope. It's created by something called the geodynamo effect. This happens because of the movement of molten iron and nickel in Earth's liquid outer core. Think of it like a giant, churning, electrically conductive soup. Heat escaping from the core causes currents in this liquid metal, and when you combine that with Earth's spin, you get electrical currents that generate our planet's protective magnetic field. This model explains why the field exists, why it has a north and south pole, why it changes over time like those wandering magnetic poles Halley noticed, and even why it sometimes flips completely. A hollow Earth just doesn't. Modern satellites also back up the solid Earth picture. These satellites can take incredibly precise measurements of Earth's gravitational field and its exact shape, which isn't a perfect ball, by the way. It bulges a bit at the equator and is slightly squashed at the poles because it's spinning. These detailed maps of how Earth's mass is spread out line up perfectly with a solid layered planet, not a hollow one. And finally, Things we can see happening on the surface, like volcanoes erupting and tectonic plates moving, also point to a dynamic, solid, or at least not empty interior. Volcanoes spit out molten rock or magma from deep within the mantle. Plate tectonics, which is just the slow drift of Earth's giant crustal plates, is driven by slow-moving currents within that solid but gooey mantle. All these basic geological processes make sense with a planet that's hot, dense, and active on the inside, not one with huge empty spaces. The science is pretty overwhelming and clear. The Earth is not hollow. Decades of research from all sorts of fields, geology, geophysics, planetary science, have given us a consistent picture of a solid, layered planet. The evidence from seismic waves, gravity measurements, our understanding of the magnetic field, satellite data, and what we see happening with volcanoes and plate tectonics all points to the same conclusion. The idea of a hollow Earth, as cool and intriguing as it is, just doesn't match up with the basic laws of physics and the actual data we have about our world. There's simply no scientific proof for it. So if the science is so definite, why does the myth of a hollow Earth keep going? Well, part of it is definitely because it's just such an awesome idea to imagine. Secret worlds, hidden civilizations, unexplored lands, right under our noses. It feeds that basic human craving for mystery and discovery. It's the ultimate what if. And because it has roots in really old myths and folklore, it feels timeless and part of our shared stories. These ancient tales of underworlds and people coming from inside the Earth have been passed down for generations, kind of seeping into how we think about the world. And let's be honest, popular culture has done a lot to keep the idea alive and kicking. From exciting novels and blockbuster movies to speculative TV shows and internet forums, the hollow Earth keeps getting explored and reinvented, often blurring the lines between fun fantasy and fringe theories. These stories, while super entertaining, can sometimes make an idea that's been disproven for ages seem like it could still be true. The internet especially is a place where these theories can find new fans and spread like wildfire, sometimes even dressed up as secret truths that they don't want you to know. This whole trip from ancient myths to modern science really shows how curious we humans are and how far we've come in figuring out the universe. What do you think about the hollow Earth theory? Did you ever secretly, or maybe not so secretly, hope it was true? Let me know down in the comments. And if you had fun on this little journey through history and science, please hit that like button, subscribe for more adventures into cool topics, and ring that notification bell so you don't miss what we check out next. The story of the hollow Earth is a really neat look at how human imagination, history, and science can all mix together. For centuries, the thought of huge hidden places under our planet's surface got mystics, scientists, and adventurers all excited. It sparked incredible stories and even pushed people to go on real quests for polar openings they thought led to new worlds. That pull of the unknown, the promise of ancient secrets, was just too strong for human curiosity to resist. But as our tools for understanding the planet got better and better, the cold, hard science started to show us a very different reality. Seismic waves showed a layered, mostly solid interior. gravity and magnetic field data gave us solid proof of a dense, active core. So while the romance of the hollow Earth is pretty powerful, the careful work of science has shown us what our planet is really like. That doesn't mean we should just forget about these kinds of myths, though. They show us how much we love to explore, to wonder, and to imagine what might be possible. The hollow Earth theory, even though it's been scientifically debunked, is a great reminder of how much our understanding has grown, and why it's so important to think critically and look at the evidence when we're trying to understand the world around us. The real Earth, with its churning molten core, its slowly shifting continents, and its incredibly deep and complicated history, is honestly just as amazing as any make-believe holosphere. The real adventure is in uncovering its actual secrets.